Today we are going to have a look at the partial fractions. Now, if we are given a term to integrate and there are two terms at the bottom, we cannot integrate that term. For example, if we got a term something like, if we got a term, for example, integration of 1 over x dx, the integration of that one is ln x plus c. That's the rule you need to remember. If it is the rule states that when you are integrating something at the bottom, the differential of that thing should be on the top. Differential of that should be on the top, and the answer you can write is as ln of a box. Okay. Now, let's say we got a situation where we have x cube plus a 2x plus 1. And on the top, I have a 3x square plus 2. If you have a look, the bottom one, differential of the bottom, if you differentiate the bottom, it's on the top, isn't it? So you can write that one as ln of x cube plus a 2x plus 1. Do not forget to add the c at the end. So whenever you see this rule, that's how we that's how we integrate. Thank you. Okay, now what if we got a term like this, 1 over x squared plus 5x plus 3? To do that one, first what we need to do is we need to convert the term into its algebraic fractions. And then we have to write down in the form the partial fraction. So here we will learn how to convert into partial fractions and so on. So let's have a look. So let's say we got a case like this and we are stuck. So we need to convert the bottom one into partial fractions first, and then we can integrate. Okay. Now then there is a thing called degree of polynomial is the highest power of the x. So if I write x cubed plus 7x, the highest power is x cubed, degree is 3. Okay. If we got algebraic fraction where degree of the numerator is less than the denominator, this is known as the proper fraction. And if the degree of the numerator is greater or equal to the degree of the numerator, it is known as improper fractions. If we got improper fractions, we need to convert that into a proper fraction, and then we need to work from there. Okay, let's go to the next one. Now, let's say we got this thing. I want to integrate x over 2 minus x and x plus 3. Now, if we have a look, if I multiply, I don't have to, but if I multiply the bottom one down, I will get something called minus x squared plus something, yeah? So, which means the degree at the bottom is higher than the degree at the top. So, this fraction is... So, this fraction is okay, where the bottom degree is more than the top one. Now, so if we got a fraction like this, x over 2 minus x over x plus 3, we can write that one as a over 2 minus x plus b over x plus 3. So we can write it like that way. Now, we do not know what are the values of the A and what are the values for the B. So here we leave this side as it is. So we're not going to solve this side. So we're just going to leave this side as it is. And we're going to have a look at to solve this side. Now, to solve this side, what we do is, let me just do that one. I got A over 2 minus x plus b over x plus 3. The first thing we do is we just put the brackets here. And then we just cross multiply. So this goes here. So this thing will multiply here and this will multiply here and they two multiply together. So let's have a look. We put a positive sign. A is here. This x minus 3 will come on this side. Sorry, x plus 3, not minus. B is there. This 2 minus x will come on this side. And at the bottom, you multiply them together. Yeah, so we got that bit. After we got that bit, we need to simplify. Multiply by the a inside. You will get ax plus 3a plus 2b minus bx. Divide 2 minus x and x plus 3. We do one more step here. Where we put everything that is an x together. So it got ax minus bx because they both have an x plus 3a plus 2b because they are constants. Divide 2 minus x plus 3. Now remember, this whole thing was actually in fact equal to this. So I'm just going to rewrite that thing. This was equal to x divided by 2 minus x and x plus 3. If you have a look, this x minus 3, this denominator and this denominator, they are same. So what we can do is we can straight away just cancel that and cancel that. Once we cancel that, we only left with a numerators, the top one. To deal with the top one, this is what we're going to do. We're going to look at x. X equals, this is, if from this one, if I take the x common, I'm left with a minus b. And I've just taken the x common from these two, if I take the x common. Plus this 3a plus a 3b, it's a constant. So that's one thing and that's another thing. Now what you can do is you can match the coefficient. You see here, there is a coefficient of x which is 1. So a minus b has to be equal to 1. So if I write that on the next one. So there is a x plus 0. Let's call it 0 because x plus 0 is that same thing. And that is a plus b. Is it a plus b or a minus b? A minus b, sorry. A minus bx plus 3a plus 3b. It's not 3b, sorry, it's a 2b. That's a 2b, not 3b. 3a plus 2b. Yeah. Okay. So I'm going to match the coefficient. So x, there is a 1 there. So the coefficient here is 1. So I can write on 1 equals a minus b, which will give me a equals to 1 minus b. Yeah. I got the a. Now, if I have a look at this one, it's 3a plus 2b. That's equal 0, which means 3a is equal to minus 2b, which means a is equal to minus 2b over 3. So I got the value for the a. Now this value for the a, I can actually put that one here. So this equation, I'm going to call that one equation 1. I'm going to call that one equation 2. So I'm going to put the value of the a back into this equation. So I go 1 minus b equals minus 2b over 3. So now I'm going to solve the equation. Move that 3 on that side. So that becomes a 3 minus 3b. You multiply this thing on this side. Yeah? That equals to minus 2b. Now move the 3b on the other side. So minus 2b plus 3b equals 3. If I solve it further, 1b equals 3, or b equals 3. Now I got the value for the b. I need to put it back in this equation. So a equals to minus 2 times a 3 over 3, which means a equals minus 2. So now I got the value for the a, and I have got the value for the b. So b is 3 and a is minus 2. Once I got these values, I will go back into this equation. And I will put the values for the a and the b. So this thing will become equal to okay, so the denominator remains the same. And then we go back and we put the values. B is 3, A is minus 2. So B is 3, A is minus 2. Okay, I've just realized this is, thank you for pointing it out, this is a plus B because the minus B become a plus B. So that will be a plus B, and then it will be here is going to be minus minus 3b. So that's going to be a minus 5b, isn't it? So that will change the whole thing. Okay. So that will be a minus 5b. Thank you for pointing it out. So minus 5b equals 3. So b is supposed to be 3 over minus 5. Then if we put this thing here, that will be, okay, I put the wrong value, so that is minus 2 over 3, and then there is a b. b is 3 over minus 5, which means the 3 and the 3 kind of cancel, and a should be equal to 2 over 5, because minus 2 over minus 5 is 2 over 5. Now once you got these values, you need to plot these values here. A is 2 over 5, so instead of a, you're going to put 2, and instead of b, you put 3 over minus 5. But when you put minus 5 here, it will make this thing minus, so that will become a minus, and that will just become a normal 5. So this is how we do a partial fractions. Okay.